Yes, now it's there. Well, anyways, also to remind that we are recording, so be mindful the way that you want to ask questions that we are at this moment recording. Well, welcome everybody. I'm really sorry for being a privacy engineering meetup. We already have to start with these technical issues, so really typical. My name is Isabel Barbera, and yeah, I work as privacy engineer, AI advisor, and I'm the kind of privacy engineer visionary that created this group in 2019. So it's still alive after so many years, and we keep growing the amount of members. So that's really great to see that the field of privacy engineering keeps growing, given the importance that it's getting. We are a bit out of time, so I think Dave, you already gave explanation about what is the initiative of the group, and especially collaboration between industry, research, try to eventually learn from each other. I won't say too much more because I want to really give the floor to Uzy Hadad and what he has to tell us about generative AI and the trade-offs with privacy, and how we can learn something out there. So Uzy, the floor is yours.
Thank you very much. Thank you for the invitation. So today I'm going to speak about balancing innovation and privacy. And before I introduce myself, I would like to start with an interesting story that occurred last month. And the question that I would like you to have in your mind: what can we do? What can we learn from this mistake? And what can we do to prevent this from happening again? So here is the story of Chevrolet. This is the story about Chevrolet. Chevrolet released on their website last month a chatbot, and this chatbot was backed by ChatGPT 4. And some user realized that it's basically a full free version of ChatGPT. And then they started to ask different questions which are not relevant to the business of Chevrolet. So you can see on the left side, interesting example that someone asked the ChatGPT 4 to write a Python code to solve some well-known financial mathematical equation. On the right side, someone asked a question about the competitor, about Tesla. So this was a very embarrassing case to Chevrolet, and they closed this vulnerability. But as you can see, when you embed a generative AI solution in your product, it might raise some risk, like some unexpected usage of your solution. And we will see later on in this discussion that there might be additional privacy and security risk. So a bit about myself. So my name is Uzy Hadad. I'm the co-founder and CEO of Privya.ai. I have a PhD in mathematics and computer science from the Hebrew University, and I have a postdoc from the Weizmann Institute of Science. I have a long experience in machine learning, privacy enhancing technologies, and also big data. So the agenda for today, I'm going to start with explaining what is generative AI, and then I'm going to explain what is the difference between classical software and traditional machine learning and generative AI, and then a bit about type of generative AI and technologies beyond generative AI, and then some breakdown into the privacy and security risk associated with generative AI, 1 or 2 slides about the regulatory landscape, and then conclusion and future outlook about that. So let's start. So what is generative AI? So generative AI, basically, it is an umbrella that refers to a artificial model, intelligence model that have the capability to generate content. So we are all familiar with ChatGPT, but there are many others. There are generative AI that generate code. There are generative AI that generate images and video and music and many others. The most well-known are Midjourney and DALL-E for images, and ChatGPT and BERT for text. Now, the basic question we like to ask, what's so unique in generative AI, which is different from the traditional machine learning model? Both machine learning model and generative AI are based on neural networks. So what is the difference? So the main difference is the fact that in a regular and traditional machine learning model, the model is try to learn how to classify or how to separate a specific data set and specific labels. So for example, we are trying to classify 0 or 1 in handwritten digits, or we try to develop a face recognition model. But in generative AI, the idea is not to learn how to classify or to separate points in the space, but basically to learn the distribution of your space. So for example, the distribution of your facial distribution, or the distribution of all the handwritten digit. And based on the fact that the generative AI learned the distribution, it has the capability to generate new results. Okay, so now let's do a breakdown into exactly what is the difference between the traditional machine learning and the classical software and the generative AI. So classical software program, let's take, for example, you have an array of integers and you would like to sort them. So you write a code for the sorting, like a bubble sort, merge sort, whatever. And this is a well-known algorithm. This is a deterministic algorithm. So this is the way that classical software program work. In machine learning and regular traditional machine learning, the machine learning software it's based on dataset sample. And in generative AI, it's not only based on dataset sample, but also some kind of randomness. And so this is the way that generative AI generate new dataset. So the next thing is, what does the model learn from the data? In classical software, the answer is not applicable because the software itself doesn't learn anything from the data. In machine learning, we learn how to separate between label, how to classify, how to predict. In generative AI, we try to learn the distribution itself. And now what about the input and the outputs? Again, in the classical software program, the input and the output are well-defined and well-structured. In traditional machine learning, the input can be structured or unstructured, but usually the output is well-defined and structured. Now with generative AI, both the input and the output are unstructured. So you can write text and get, as a result, text. You can write text and get an image. You can write text and get a code. So it's very, very different from the other solution and the other software, traditional machine learning software in the market. Last bullet is about the data reuse. So there are no meaning for data reuse in classical software program. In machine learning, there is a meaning for data reuse, but it's usually very limited. It requires a lot of effort to take the data that the user insert and then reuse it in the next model. But in generative AI, it's more common to reuse the data that they get as an input. So after we understand the difference between machine learning and generative AI and what is the fundamental idea behind generative AI, so I would like to give a few words about the technologies behind generative AI. So currently we have two well-known technologies. One is called large language model, LLM. So we all know OpenAI, BERT, or Claude. So this is a model we generate text. We also have a diffusion model, and the well-known application of this model are Midjourney and DALL-E. And we have additional technologies in generative AI, like variational autoencoder, and generative adversarial network. But the first two are the most well-known and the most used now in the market, but all of those technologies are based on artificial neural network that were introduced in the 60s, but only in the last 10 years, we see such an advance and improvement in the hardware, and then also in the software, and we see such a beautiful technologies and innovation in the market. So now let's speak a bit about the challenges regarding generative AI and machine learning in general. So the first term that I would like to introduce it is called explainable artificial intelligence. So you can see here on the right side an example that happened with GM, a self-driving car made an accident, and now there is an investigation. And now we need to understand what was the cause for the accident. So the cause can be because there was a problem in the camera, there was a problem in the model, the feature that we try to classify or to extract from the image was not accurate, or it can be something in the model itself. So there are many questions, and the answers are very important because we like to know who is responsible, and also we like to fix this problem. So this is the idea of explainable artificial intelligence. And now the challenge is the fact that with all the sophisticated machine learning and generative AI solutions, which are based on a very deep neural network, it becomes very, very difficult or even impossible to find the cause for a specific problem of a specific case. Anyway, the regulation already involved on this part, and you can find some requirement that in some cases, let's take example like if a bank reject a loan or approve a loan, then the bank need to explain what is the reason for the rejection or for approval of the loan. So this is a very interesting and emerging topic. It's based on what is called interpretability. So this is the degree to which a human can understand the cause of a decision. Now we'd like to take break it down a bit, and present additional concept, which is called machine unlearning, or in the privacy terminology, it is called data subject requests for AI. So the problem goes as follows. Generative AI and sophisticated machine learning model are trained on millions of data points. Sometimes, instead of learning the pattern or the structure of the data set, sometimes they can remember the data itself. So if the data contains sensitive information, the model or the generative AI might really remember the data itself. So it can output it in the next request or in the next content that it will generate. So this can be very embarrassing. And let's think about a case that something like that happened, and then a user asked to exercise his right to be forgotten. Okay, so we all are familiar with this right. It's well known in every privacy regulation. Now let's see how can we can resolve and fix the problem in a data set. So we can go back to the original data set and then search for this specific person and then try to remove the rows related to this specific person. But the problem is a typical generative AI model can cost more than $1 million and also probably takes more than a month for training. So it's a huge cost, and you cannot do it on a regular basis. So because of that, you need to take into consideration during the development, during the training, the fact that the data set should be anonymized or even need to add some kind of noise to prevent someone from being identified in the generating content of your generative AI. So you can see there's two ways to resolve it, like anonymization and the noise, but we are here in a meetup of privacy engineer, and I believe that most of you are familiar with the privacy enhancing technologies like differential privacy, and federated learning. Anyway, it's not an easy task to, if we all know from differential privacy, it's not an easy task to add noise. And there's a lot of questions associated with that, also with anonymization. And so this is a real challenge if you're going to train your generative AI or on a data set which might contain sensitive information. Now I would like to give four cases of privacy and security risk in generative AI, which are already well known. There are more cases, and I just choose only four of them. So let's start. So the first one is about algorithmic discrimination. So you can see here on the right side a story that 1 million of Black people were affected by racial bias in healthcare algorithm. Again, the reason for the bias was the fact that the training data set was not a good representation of the distribution. And because of that, the model in some way was overfit to the training data set. And because of that, the result was algorithmic discrimination. Another example is more about data poisoning. So this is an example of a chatbot that was developed by Microsoft in 2016. And then they released it as a chatbot in Twitter. And after 6 hours, it started to write offensive tweets, and it was shut down. So this is one of the challenge, one of the risks in using generative AI, which is without checks and balances. By checks and balances, I mean if you add filter to the input of the generative AI and also add additional filter in the output of your generative AI. So this is the way you can prevent this case from happening. Another thing which is very interesting is about the copyright of some of the generative AI. Some generative AI are trained on a public data. It can be the internet itself. It can be code. In this case, we speak about Copilot, which is a solution by Microsoft that was trained on open source code in GitHub and etc. And there are some question and concern about the copyright of the result of generative AI, if it's belong to Microsoft, it will belong to the user that originally wrote the code in the open source. So this is very interesting question, and there are some AI lawsuits about that. Last example in privacy and security risk is about data security breach. So it turned out that many of the machine learning and the generative AI might contain a security vulnerability. I just gave here one example of a recent research that was done in Lancaster University. And you can see here that those researchers find a vulnerability in the large language model, and they were able to extract interesting and sensitive information about the model itself. As we all know, the OpenAI model is a closed model, it's not an open source, and they were able to attack the model and extract interesting information. So this is one example. There are many other examples. There are examples of attacking a biometric solution, and people were able to extract information, biometric information about the user that were stored in this specific biometric system. So as we can see, there are many challenges associated with machine learning and generative AI. And now we'd like to speak a bit about how to do the mitigation and a bit about the regulatory landscape. So we saw that the cost of fixing a problem in generative AI and machine learning in production can be very high. So the recommendation is to do mitigation before deployment to production. So this is the first thing. The second thing is the fact that a breach might happen and probably will happen. So because of that, you need to designate an accountable person for case of AI breach. And AI breach is something similar in some way to the regular breach, like if someone compromised your database, but it's contain a different response because it involves generative AI, it involves training data set and some kind of poisoning and other risk, which are not typical risk that we all know from the regular data breach that we know in the market. A bit about the regulatory landscape. So the most advanced regulation about AI is the EU AI Act. It's still a draft. Probably it will take effect in 2025. There are additional drafts like the ADPPA federal draft in United States. This draft also contains a section about AI algorithm. There is a NIST framework about AI. So it's a very interesting area for regulation and for best practice and best practices. Another thing that related to the regulation is the EU AI Act already introduced and categorized the following application that might regard with high risk if they use machine learning. So you can see the biometric, you can see management and critical infrastructure, education, and many others. So companies that develop application of those type and are trying to embed or a machine learning generative AI need to take it very seriously because those applications are already being classified and probably the regulation will take a real care about them. Okay, so now I would like to move a bit from the risk, and I would like to show you what we do in Privya and how Privya use generative AI in a responsible way. So before I will explain how we use generative AI, I'll first explain what we do, what we develop in Privya. So Privya is a code scanning solution that scans code, and we use machine learning and graph model to classify all the usage of PI data, third parties, machine learning model, databases, and etc. And you can see here, for example, you see 6 repositories that we scan, and you can see that in the first one we found 18 personal data, 10 sensitive, and 6 secret, and we also found about 6 third-party integration with third-party. But more than that, we also classified the purpose and the entity. And because you are coming from the privacy space, we all know that the purpose is very important as part of the regulation. You need to validate that the purpose of this specific application is according to what you have in your contract or in your consent, and etc. So how Privya classify the purpose? So the way that we do it, we basically use our own large language model. So we take the code and we embed it in our large language model, and then we try to classify the purpose. So and we do it in a very responsible way. So we provide a predefined list to our large language model. So the classification can be the result of the classification is one of the items in our predefined list. So this is a way to do some kind of checks and balances, to do filter on the result and validate the result will be according to what is expected. And there's no case to see here something that generative AI will generate which is not relevant to the purpose or for the entity. So this is basically what we did in our solution. So this is first thing. The second thing that I'd like to speak is how to use Privya to mitigate the risk associated with generative AI. So the first thing that I'd like to do, I'd like to ask the following question. How many generative AI or machine learning model does your organization currently use? So this is the first question, a very important one. Then what is the data being consumed by the model? And the third one is how many of them are integrated directly with customer-facing system. So with Privya, we are able to answer all of those questions. So you can see here a screenshot from our solution. So after we scan the code, we have a place that, sorry, totally jump. We have a place that you can see all your machine learning models. So you can see we find a model of OpenAI, we found an internal model which is based on TensorFlow, and we also found a LangChain model. So you can drill down and you can see which project use the OpenAI model, what is the classification of the data that we'll share with this model. So it gives all the relevant information during the development to mitigate all the risk associated with this model. Now, more than that, because we scan the code during the development, we encourage our user, our customer, to open a channel directly with their engineer. So you can see here, we raise alerts about usage of OpenAI, and we also classify the data, sensitive data that was shared with the OpenAI, and we give detail about this specific problem and also how to remediate. And we also have connection, integration with Jira and Azure DevOps, so you can directly send this ticket with a recommendation, with instruction, how to remediate the problem. And here is this is the problem, the risk, as we already understand, with generative AI can be very high. So we recommend the first thing is to validate the inputs that you send to your generative AI. Don't copy and share your data directly with those systems. It's probably remind SQL injection. Also in SQL injection, you need to do validation of the data that your user insert before you send it to the database. But in here, we also need to validate and check also all the outputs that the generative AI generate before we share it with our customer. So I just show you in Privya the way that we do the validation. We basically try to find the best match of the result of generative AI from a predefined list. So basically, this is a good way to put a filter and to prevent case of data poisoning or a violation of your privacy or your security. And the last thing is, if you build or if you have a solution that is a decision support system, and in the backend you have some type of machine learning or generative AI, then it will be very, very, very risky if you will do automation based on the result of the generative AI. So the recommendation is to avoid automation, to have, again, some checks and balances on the filter before you take the result of a generative AI, before you use it in a decision support system. Few takeaways. So there's always tension between AI innovation in general, and risk. So AI risk cannot be eliminated. It can be reduced, you can mitigate some of it, but there are always some kind of risk, in particular with generative AI, which is based on very deep neural network, and it's very difficult to understand and to explain the results. So because of that, incident can and will occur. So you need to take it into consideration, and you need to designate someone in your company to be the owner of your machine learning and generative AI model. And so in case that there is an incident, he or she will be responsible for the incident response and to manage the events. Last but not least, we believe that responsible development is a good approach to prevent cases of data violation, privacy violation, privacy poisoning and data security vulnerability in generative AI. So the recommendation is to be involved during the development life cycle and mitigate and add checks and balances instead of trying to fix the problem when you are already in production. Now it's time for a question. There are questions.
Thanks a lot, Uzy. I'm really happy that you are sharing here your knowledge about generative AI with us. I have a lot of questions, but yes, you know, this is also the series that we have in the meetup group. It's called Dissecting Pets. So we like to ask how your product really works. The purpose of the meetup group is never a commercial purpose, but this really great tools, and we want as engineers also to understand, not only engineers, whether it's working in the field of privacy and security, to understand what is really, how the really things work, and are they really doing what they say they do, and this is really a place to really ask those questions. So I want to let first on the floor to the participants if anybody has a question. I know there was a question on the chat about liability. I don't know, Renert, you're still with us, and you want to ask yourself?
I can. Well, it was the remark I posted in the chat side was not so much a question as a connotation, or basically stating that you said there was a lot of research being done about liability questions, and my response or my comment was that the suggestion what type of liability or what the outcome would be would depend on the type of law, so technical type of law used and the persons involved. So the person who answers who asks the question, but also the type of law you use has a large impact on the question of who is liable in the case of the car and the malfunction in the software. So that what there was a you can distinguish product liability where, you know, the product delivered was faulty, civil liability between the parties, so the one person driving over the other one, over the pedestrian, but also contract breach, and from the government and the permit type of situation, it is important that only safe products may be put into the market. So questions of liability are there not so much answered in the fact of who is liable, but more, is the product safe enough given the fact that some incident may occur, which is a bit complexer than just stating, well, you could have an accident with it, because then we wouldn't be able to have any products in our environment, because everything can go wrong. But the fact is, when is it too dangerous? And there is a lot of debate, of course, on when provided, you know, in the US or in the EU or different types of countries and legal systems, those permits and those requirements are handled differently. But there's a lot of debate about that going on.
I can tell that it is complicated, especially when it comes to the burden of proof, and when you have to demonstrate that something has gone wrong. And I believe within Europe, we are also looking into creating a kind of a liability directive, at least only specific for AI, and not just the general one, to compensate for these shortcomings. But it's been an issue.
Yeah. Depending on.
But I see you know a lot about that, Rainier, so you should come another meetup here to talk to us about liability of AI.
Well,
this is a very interesting question, but a very challenging one for sure.
Yeah.
Liability.
But I have a question with regard to the software. You stated that it checks or it verifies the output before it's handed over to customer or the user who requests the output. And my question would be, how is that process being handled, and how do you prevent it actually that in that situation, Privia is actually being seen as an extra person who is handling personal information? So say the output consists personal data, it has personal data in it. You wouldn't want to process personal data because you would need a data processing agreement. So the question is, how do you do that currently? Can you tell us a bit about that?
So just to understand, you ask about Privia, how do we do it in Privia? How we do the classification in the purpose, or how we do it in our product?
Well, I can imagine.
Clarify here, because I think, and that is related to one question that I have, if your product can run only on premises, and then is the customer making use of the model that can even self-customize to identify their own personal data related to their specific domain, for instance, or is that tool that runs in the cloud with a model for all clients? So I'm just curious, because that also has an impact with the questions from I think René. Yeah, regarding the type of agreement that you will have, if you will be yourself also processing personal data, or it's just at the premises of the client where you don't really have anything to do with it. Just wondering.
Okay. I will answer the question. So our solution can work in SaaS, in Amazon, or also on-prem. We are not processing any personal data, only the name of the one that wrote the code, but basically we just scan the code. So what we provide a solution that classify all the usage of machine learning and PI data in the code, and then we give a recommendation and suggestion how to mitigate the risk. So for example, to add some kind of filter before you send data to your generative AI, and also to add a filter before you take the output, the response from generative AI, and send it to your end user. So this is basically what we do in our solution. Again, we are not processing, we are not involved in your production, we're just scanning the code in the development, and we are part of the development lifecycle, and we try to fix the problem from the get-go. Does it make sense?
Well, I think it makes up to a certain level. It does make sense, but I was curious because I found the question of Isabel quite good, in the fact that if you say we scan, I think you mean the software scans it, and for the answer of whether you would need like a data processing agreement, it would differ if it were to be an in-cloud application, or the data would be transferred to Privia itself, or whether it would be on-premise, either in a private cloud or in a on-premise local situation, the software would be handling it. But that was, I think, what Isabel was getting to, right?
Yeah, it makes a difference in the relationship. So if you really have yourself access to the personal data, and I can imagine that your own scan, the way it recognizes data, because that is also related, by the way, to another question I have about how the classification is made, is based on the input from the own user, is based on like best practices on regulations, because I can imagine that it's like all these data prevention tools for email, so you can decide yourself, you train the model, so it's more domain specific, because maybe some data for you is more sensitive than other, depends on your region, your specific domain. So I was wondering, how does it really work? Because if it's like a system like in the cloud, it's like general for everybody, so eventually you might have some access to personal data. You will need to have, like René was saying, some agreement there. But if it's just something as can running on the premises of the clients without you having more access than well, at least not the data in itself. And the users are doing their own classification and kind of fine-tuning the model. So
yeah, so basically what we do, we use the best practice of all the classification in GDPR and CPA and other regulations. So this is the first step. This is the building block. This is what you provide as is. You can also customize and do tuning according to your needs. So you can redefine and classify different type of data according to your regulation. So we provide it as part of our solution. And as I said, we have both options. You can work with our solution in cloud as a SaaS, and you can also install our solution on-prem, and no data will go out from your VPC environment.
And what are you scanning really? Is the output or is the data set?
We're scanning the code itself, the repositories of the code. We don't scan the real data. So the only thing that related to personal data is the name of the developer. So we also signed DPA agreement with our customer, but
exactly.
the part about the PI data is very short. It's basically the IP for the for the security restriction and the name of the developer. We don't really see any personal data.
I have from my side, so I'm taking the time from all of you. I'm really, really curious about this one of the purpose. Because as engineer, lovely that you can really in an automated way, you have your purpose there established. But as a also lawyer, I'm like worried, like, how do you really do this? I mean, there's no human intervention there. And I find that a bit sensitive and dangerous. So I really want to understand how are you doing this.
Yes, so let's take, for example, you have a repository and you have a very good architect, and you ask the architect, what is the purpose of this repository? So he or she will go through the repository, will check the code, will review the code, and then he try to see, okay, there is a class about employee, and inside the class there is a function about salary, about vacation, and etc. So based on that, he or she will tell you, okay, this repository is about HR management, and the main entity is an employee. So this is basically what we do. Instead of hiring an architect to review the code, we use our own LLM model, and we try to understand from the code itself, from the context, from the terms, from the tokens in the code, what is the purpose and what is the entity. And again, we predefine the list of purposes, a long list of purposes, and predefine a list of entities. And then we ask our large language model to find the best fit between what the model thinks, what the model classify, and the list that we provided.
And is this something that customers can customize?
Yes, the customer can, yes.
Like an error, I can imagine you will need to say it's right, it's not right. So in that way, you are also teaching the model.
Exactly. The customer can also customize and tune and improve the model.
So it's possible for a customer to have a custom model itself.
Exactly.
That's nice. Well, now I let the floor for others if there's any more questions.
I think we are done.
No questions.
No question. Thank you very much. Thank you, everyone.
Yeah, thanks so much. Thank you so much, Uzy, for your time. And I think it was a really interesting discussion. Talk about the legal side, the technical side. So good to understand the technologies that are there outside and how we make use of generative AI one way or the other. Also to help solve these privacy and security issues.
Thank you. Thank you.
Okay. Well, with this, I don't know, Dave, you want to say also goodbye officially?
Well, I started the session, so I'm going to close it all. Welcome, everybody. Thanks, Uzy, for this nice presentation, everybody. Thanks for having the great discussion, and we hope to see you next time again.
Yeah, will be soon.
Thank you.
Okay,
Okay,
bye.
thank you, everybody.
Bye-bye.
Bye.